Alright, so now that we have figured out how to solve circuits when they're wired in just series or just parallel, we can move on to more complex combinations of them. And again, by solving circuits, what we really mean is just finding the missing values of voltages and currents based on how we know voltage and current behave when things are wired in series and parallel to each other. So we're going to use this chart. Again, this chart is going to be super helpful and valuable as we analyze this circuit. So again, first, before we even want to tackle this, we want to figure out how are things wired. All right, so we got, let's see, resistor A, resistor B, resistor C hooked up to this battery. How would you classify that? You're going to need 2 sentences. Go. Yeah, I would say resistors A and B are wired in series to each other, right? Because they're in the same branch, same path. And then that branch containing resistor A and B is wired in parallel to resistor C. And a kind of a shorthand way of saying that is A and B are wired in series with each other, but the AB branch is wired in parallel with C. I'm calling this the AB branch because it's the branch that's got resistors A and B in it. So, you know me, as we start to solve this, I like going voltages first, so that's what we're going to do here today. I've got 2 missing voltages here, and the only voltages I do have are here. So I think I'm going to use that to kind of get the voltage across the battery, and then maybe that'll allow me to get the voltage across here. Hopefully you're already kind of seeing the pattern and being able to fill this in, but we're going to show you how to show that work now. All right, so we're going to start off with this, right? We know these are wired in series, and I know how voltage works in series, right? Voltage in series is just conserved, so they add up to whatever's being supplied. So A and B should add up to whatever's supplying that AB branch with voltage. In this case, the AB branch is being supplied with voltage straight from the battery, so these should add up to whatever the battery is. So I can start off with A and B are wired in series, right? Because now we're going to break it down into very small chunks, which will allow us to say VBAT equals VA plus VB. We know we got 7 and 5 volts across A and B, so that means the battery's got to be giving us 12 volts. And now that we've established that, we can then in a separate sentence, a separate claim evidence reasoning, explain why VC is going to be what it is. And like we said, these are parallel branches. And we know parallel branches from our chart, right? Parallel branches are going to get the same amount of voltage. V branch 1, V branch 2, V branch 3. So if I've got 2 parallel branches, and this one's getting 12 volts, well, we know that C is wired to the RA-RB branch, so the AB branch. And we know that parallel branches get equal voltages, so we can say it like this. The voltage across the battery is supplying it to these 2 branches, the AB branch and the C branch, and that means each branch is going to get 12 volts. And since there's only one thing in this branch, it's going to get that full 12 volts. It doesn't have to split it with anybody. And on that note, here we've got 2 resistors. One's got 7 volts, one's got 5 volts. We haven't solved for any currents yet, and we don't actually have to determine which one of these 2 has the bigger amount of resistance. So take a second, think about it. Which one's got more resistance? Why? Yeah, resistor A is going to have more resistance because it is getting more of the shared voltage. Right? They're not splitting it evenly, so this one's going to have more resistance than this one. We know how voltage works in series. I don't want to give away the answer for the current there, my justification there, but we do know that things with more resistance use more of the voltage being supplied. So since it's getting more voltage, it's going to have a higher resistance. All right, now we can start to tackle the currents, and we're going to kind of have to do it. This one actually isn't too bad. So again, we know that, let's see, so we got 2 missing currents here. Well, we've got 2 parallel branches, right, going to the battery. So let's think about it that way first. So before we even tackle these ones, let's think about it as like just figuring out what's happening with the branches. We know we're supplying 1.15 amps of current, and we know that in parallel, the current from each branch adds up. So if these 2 branches are adding up to give us 1.15, well, we can figure how much is going across into this branch. So we can start by saying that RC is wired in parallel to the RA-RB branch, kind of like we just did in our last one, right? That was our justification here. So we use this parallel combination descriptor. We're going to use that for current again. And that's going to allow us to say that the current across the battery is equal to the current through the IA branch, to the AB branch, plus the current through the C branch. Right? And that might look a little bit weird, but all we're saying is that the current coming out of here is going to be equal to the current that goes through here plus the current that goes down this way, right? That this junction here is where the current splits up. Some of it goes this way, some of it goes down this way, but those two will definitely add up to this right here again. And since we've got that, we can just fill in the blanks and figure out that there is 0.26 amps of current going to the AB branch. But we also now need to be specific about how we can get A and B from that, right? That only tells us how much goes to the branch. That it kind of implies how much goes through each one, but we want to be really clear about that. We know that A and B are wired in series, and again, we know that in series, current is just straight up equal. So all we got to say is that the current through the AB branch is going to equal to the current through A, the current through B, because that's what it means to be wired in series. And yes, this might seem like a little bit of overkill right now, but trust me, once you get to really complex circuits, being able to break this down and being clear like this is going to help you very much so, because we're going to start putting circuits within circuits within circuits, and it's going to get really complicated. So being able to break it down into small steps like this is going to be really, really important. So on that note, why don't you, now you've only got the rules for current here, take a look at this one. Now you can replay this whole section if you want to check out how those are wired, but I want you to try and tackle this one and see how 4 goes. Good luck. All right, let's take a look. Hopefully you came up with some good stuff here. Again, you know me, I'm going to tackle this in terms of voltage first, and then we'll go into current. Now it's wired the exact same way, so we're going to use the exact same justifications, right? We got A and B wired in series with each other, and that AB branch is wired in parallel with C. So we're going to start with by here saying that RC is in its own branch connected to the battery. So yeah, we didn't really talk about how it's in parallel, right? Well, I mean, we're kind of saying it's in parallel, right? Another way you could say this is RC is in parallel to the battery. But that's kind of confusing thing when we talk about the battery. So I'm going to say here RC is in its own branch connected to the battery, which tells us that we can treat it like the parallel rule, right? So VBAT equals VC, so VBAT equals 9 volts. And then the next thing we can say is, now if we're continuing on with the voltages, well, R and B, our A and RB are wired in series. And what that means is that the VBAT is equal to VA plus VB. So I didn't even really talk about here how C is in parallel with that, because I've already implied it, right? We already talked about how these are in 2 parallel branches. But what we could say is RA and RB are wired in series, and the AB branch is in parallel with RC. So that allows us to kind of make that connection there. So you kind of need both of those sentences there to really claim this. But once we've got that, then it becomes easy, really easy from there. And we can just say that VBAT equals VA plus VB, plug in the numbers we know, subtract out, find out that A is going to have 3.5 volts. Again, filling in these numbers might be easy, but justifying why they are, that's the part we're really practicing here, because they're going to get even harder than this. So now let's take a look at how the currents are working here. So current. Interesting. Okay, well, I see these two here wired in series with each other, and I know straight up that when things are in series, how does current work? Yeah, in series, current's just straight up equal. So I'm going to start with that and say that A and B are wired in series. So the current through A is equal to the current through B, is equal to 0.07 amps of current. Right? So the AB branch is equal to A is equal to B. Right? So they're all in series in the same branch. And then, now that I've got that, I know how much current is down here. Because if I know that the battery is supplying 0.47 amps of current, and I know 0.07 is going down this way, the rest has to be going that way. Right? Because that's what conserving means, right? The total adds up. The total stays the same. So we can then move on from there. Wrong button. RC is wired in parallel to the RB branch. So IBAT equals IAB plus IC. So we know we got 0.47 amps of current total. 0.07 goes to this branch. The rest is going to go to the C branch. leaving us with 0.40 amps of current. So yeah, hopefully you got those. If not, definitely want to stop into a Zoom session or send me a message and we can figure out something together and get you all set, because it's only going to get harder from here. So let's ramp it up to the next level in the next video.